Hi, I'm David Swanson. I'm a student at the University of Tennessee in Knoxville, and this is a presentation for the course Computer Science 462. I'm going to discuss the basics of machine learning and how it can be related to parallel computing. Now let's get started. So what exactly is machine learning? Machine learning is a field of computer science that gives a program the ability to learn without being explicitly programmed. It can also be categorized as a subset of artificial intelligence, where algorithms are used to autonomously learn from data collection and self-teach the program how to improve the algorithms themselves by making predictions on data. Computer scientist Tom M. Mitchell gives machine learning a more formal definition. He describes it as a computer program that learns from experience E with respect to some class of tasks T and performance measure P, if its performance at tasks in T measured by P improves with experience E. This basically says that an algorithm is considered to be a machine learning algorithm if it learns from its tasks it is completing and there is an increase in performance as a result. Alright, now here is a brief history of machine learning. The term machine learning was coined in 1959 by an American man named Arthur Samuel while he worked at IBM. The field evolved from a study of pattern recognition and computational learning theory in artificial intelligence. While researching artificial intelligence, they approached problems with symbolic methods, neural networks, and probabilistic reasoning. As the research progressed, the increasing emphasis on logical, knowledge-based approach to these algorithms caused a rift between artificial intelligence and machine learning. Machine learning reemerged as a separate field later on and started to gain popularity in the 1990s. The goal of this field was changed to focus on solving problems of a more practical nature. There are a few different categories of machine learning algorithms. The algorithms are grouped into these classifications based on the amount of learning feedback available to the system. There is supervised learning, unsupervised learning, and semi-supervised learning for the middle ground algorithms. Let me explain what each of these are, starting with supervised learning. Supervised learning is where the majority of practical machine learning algorithms lie. In supervised learning, you have an input X and an output Y, and an algorithm that maps the inputs to the outputs, such as Y equals f of x. This algorithm learns from the data input and maps more accurately as you progress. This category is called supervised because of this process that the algorithm goes through. You can think of the training input dataset as the teacher supervising the learning process. Learning in this category stops when the algorithm achieves an acceptable level of performance. Supervised learning can further be grouped into regression problems and classification problems. For unsupervised learning, you have only the input data X and no corresponding output. The goal of this category of machine learning is to model the underlying structure or distribution in the input data. This is done in order to learn more about the data and make more accurate predictions about the inputs. In this type of learning, algorithms are left to their own devices to discover and present the interesting aspects of the structures in the data. Because of this freedom, there is not any kind of teacher entity like in supervised learning. Thus, this type of learning has come to be known as unsupervised. Types of problems in this category can further be grouped into clustering and association. The last category of learning is called semi-supervised learning. This type is in between the other options. In this category, there is a large amount of input data X, and only some of it is labeled as Y. Many real-world machine learning problems fall into this area because only some of the data can be labeled because of time constraints. The goal of this type of learning is to discover and learn about the structure of the input variables and make best guess predictions for the unlabeled data points. Now here's a list of the most used supervised and unsupervised machine learning algorithms. However, this is not an exhaustive list. There are many more algorithms used in this field. I just wanted to give you a taste of what is out there. The basic function of these algorithms are listed. They all have separate goals, but the underlying structure of the algorithms are similar. For most machine learning problems, the main slowdown in the algorithm is the size of the input data set. We usually work on large matrices of data. Also, these algorithms usually only consist of simple linear algebra operations on single data points with little dependency on each other. These facts make for ideal parallel computing conditions. Operations can be split easily among CPU or GPU threads because of this lack of dependency. You can easily write parallel algorithms for these problems by dividing the input data matrix. Communications between the threads would be the only slowdown in this new algorithm. Here is a list of literature that may prove useful to anyone interested in machine learning. There's an article that covers the basics of machine learning, an article that defines the difference between the types of learning, an article containing the most useful machine learning algorithms, and an article about how all this is related to parallel computing.